Welcome to our online seminar today. Our speaker today is actually also a guest professor at ZOI and the SDG Nexus Network, Professor Dr. Min Liu from Lanzhou University in China, currently affiliated with Justus Liebig University. Min will talk about grassland restoration effects in China. I'm really looking forward to your talk. Min, you joined us in January, right?
Yes.
Under the SDG Nexus Network project, as I said. And we met before on several other occasions. I'm happy you found the time now to introduce us a bit in your research. Min, you have a PhD from Wageningen University, so it's not your first time in Europe. Yeah. You've also been to Germany several times before. And yeah, now you have an extended opportunity to learn about Gießen, JLU, and many other places in Germany. Without further ado, I give the floor to you.
Thanks for the opportunity for the guest professor. Although I just stay here for 1 month, but I had a very good time. I really enjoy my life and work here with all of you guys. So today I'm going to share my recent work. It's a paper I started last June, and recently it's under review at Nature Climate Change. Today I would like to share one part is about this paper, and also if you are interested, I also can share some experience to publish at Nature journals, because until now I had a lot of failed experiences. So if you want to know. Okay, I think I will have a half hour to introduce, yes, thank you, to introduce this paper. It has a lot of empirical analysis, so I will try my best to make it clear. If you have any questions, please ask after this 30 minutes, because we have another 30 minutes to discuss. So it's about grassland restoration increases crop yields through local climate regulation. So from the title, we can see the purpose of this paper. There are 3 things: grassland restoration, crop yields, and local climate. Yeah, so my co-author include my own student and also my friends from Beijing University and one American university, and also David Wooper. So first, the introduction. The land restoration actually is a quite important and classic topic for everywhere of the world. There are a lot of attentions on the costs of land restoration, but actually after land restoration there are a lot of benefits as well. But we actually didn't measure those benefits or not that much work to measure. So beyond the restored land per se, it has some benefits. For example, it would have some benefits on agriculture production. In fact, we knew a lot, like forest degradation would have a lot of negative impacts, but we didn't measure if the land got restoration and what's going on, what's the benefits, right? So the research question is very simple. To what extent can grassland restoration affect crop yields, and what are the underlying pathways? So here the pathways would focus on the climate change. The research area, I'm focusing on a part of China. So at the corner, the red part, the red with the map with some red, that's Chinese map, the whole China, and we take apart the northeast part. Yeah, because this part, I will tell you more why we selected this area. In China, so we focus on the grassland. In China, the grassland area is around 400 million hectares. So it's at the second largest. It's the second largest grassland area of the world, just after Australia. And in China, it's about 40% of the Chinese land, the total land. And also in this area, we will focus on the maize production. The maize production, Chinese maize production, is about 24% of the global total production. So this area accounts for 46% of the whole country's maize planting area, and about 50% of the total maize yield. So this area is called as Northern Spring Maize Region. It covers 3 million square kilometers. The area is 8 times of the size of Germany. So you have an idea how big it is. So, and then we use a policy. The policy is to protect the grassland. It's called Grassland Ecological Compensation Policy. As a tool to do the analysis. So about this policy, it's one of the world's largest ecological restoration policy. It meant to protect the grassland by controlling overgrazing. So in details, what the policy do is to ask the herders to have grazing bans or livestock forage balance regulations. So that means the grazing has a quota. So that means you just reduce the grazing number. And also the government gives them subsidies to compensate their economic loss. Yeah, so until now, there are many studies, including my previous research. We have proved that this policy already had impacts on improving grassland. So it works on grassland restoration. And the government, of course, invested a lot of money. It's over 23 billion US dollars. It started around 2010. And the map, you can see different colors. It means in different years, this policy extended from the yellow part to the green part during 2011 to 26. So until now, it's still ongoing. Yeah, the black line in the map it's the county. So one circle is a county, and so that means this policy extended based on the counties. So our research would based on the 834 counties, and the time period is 20 years. It's from 2001 to 2020, so it's 20 years. Okay, just in case you get lost, I repeat my research target. This research leverages this policy, GECP, as a natural experiment to examine whether large-scale grassland restoration can enhance agricultural production through regulating local climate. So based on our research target, we need different data. So first, the climate data, which is based on the ERA5 reanalysis data size. So it's a European Center for Medium Range Weather Forecasts. And also we use the China Met data set as a robustness check. And for the grassland quality, we use the normalized difference vegetation index, which is NDVI, as the proxy variable to measure grassland condition. That's usually how we do it. And also the crop production and agricultural inputs is from the yearbooks from the Chinese Agriculture and Rural Affairs of China Bureau. And also the important data is about the policy. So the policy is basically is based on the government websites. So they would publish when they started and where. So it's a dummy variable. Of course, for the control variables, we need socio-economic variables like GDP, those kind of things. At the same time, we also control the ecosystem services. For example, the water and soil conservation, the windbreak and sand fixation, those kind of indicators. We use the ecological models to measure them. So it's I will not go to the details here. And also another important data is phenology data for maize grace stages. Yeah, because this paper it's about later we will analyze what happened at a local climate, and the local climate actually impacts the crop yields through phenology or agronomy. Yeah, it's kind of multidisciplinary analysis. So descriptive analysis, I skip this. Okay, the empirical strategies, I'm using the staggered DID model. So it's, I guess you guys are familiar with this because it's just a very regular or very popular model. So.
We are not,
huh?
I don't think people are familiar with it.
Oh, okay. okay. Yeah, because I'm working on econometrics, so it's very popular models. So, okay, I will give you some details here. Staggered DID, it's a difference in differences model. Staggered DID because the policy started to be implemented in different years. So I showed you the map. Somewhere it started from 2011, somewhere started from 2016. Yeah, so that's why we are using staggered DID. So the equation 1, the outcome variable, here we use NDVI and the temperature and rainfall and maize yield and maize shortfall. So it's different models. We just it's a you can understand it as a vector. And the GECP is our most important concern, how GECP impacts the outcome variables. And the X variable includes, for example, GDP per capita, livestock number, population, and also a lot of others, because we need to control the initial situation. So here we use the data in 2001 times time trained. So in this case, we can control the initial situation of those variables, and also we consider the time variance. So yeah, it's here how we deal with the control variables. And also we need to control the county fixed effects and the province by year fixed effects, because DID actually theoretically it's still a fixed effects model. Yeah, and also clustered at the city level. And the staggered DID model, of course, we needed to test the parallel assumption. So that's why we are using event study model. And here, event study, it's the GECP, the policy. You will get the coefficients year by year. And the others are the same. So this one is mainly for the parallel trained test. I will show you the results later. So okay, for example, this picture. This picture that's the results already. So based on our previous models, so here the picture on the left, it's the results about the policy, the impacts of the policy on NDVI. NDVI is for the grassland condition. So this picture is based on event study model, right? So on there's a red line. The red line on the left, it's you can see it's insignificant. It's the coefficients are actually around 0. So that means the control group and the treatment group, there's no differences before the policy implementation. Yeah, afterwards, after the red line, you will see the green lines, they are above the 0, the axis. So that means after this policy implemented, what happened to the NDVI? So you can see it goes up, it's positive. And at the same time, on the right, it's a result, it's kind of the average value of the event study results. So this one is more based on, you run the SDID model directly, you will get these results. And for each, for example, the 1, 2, 3, here, 1, 2, 3, these 3, that means 3 models to prove the impacts of the policy on NDVI. So the first model, we used all the counties, but there are some places, some counties, they don't have maize production, so we just remove those samples. So the second here, So the second is, or the third column here, it's based on all the counties. So we include the long maize counties as well. And the third column, which is we use the CS approach. So it's because if you use you use a staggered DID model, there's heterogeneity treatment issues. So we need to use some other models to deal with the heterogeneous treatment issue. So that's why we use another approach. So this means, okay, we use the 3 models, but in the end we get the very consistent results. It's kind of like a robust checks. So at the same time, we checked the results on the grassland area, but actually it's not significant on grassland area. But we got our results. This policy implementation indeed impacted the grassland condition. It means it improved the grassland. Yeah, we go further. We see the policy implementation, how to impact the local climate. So the left picture is about the impacts on temperature, and the right is about the impacts on rainfall. So we see the temperature is lower, and the rainfall actually increased a bit. The temperature specifically increased 0.1 degree, Celsius degree. And the rainfall temperature decreased 0.1 Celsius degree, and the rainfall increased around 12 millimeter. And we get into the we get deeper to analysis what's going on in each month. So the results are based on the coefficients of each month. So we can see the temperature declines. Actually, it's not every month. It's in June, August, and September significantly. And the rainfall also, at the same time, we did the models on extreme heat days. So extreme heat days decreased in August, September, October. So it's kind of rely on the temperature. And the rainfall, it's mainly happened in July. And at the same time, the drought, extreme drought days decreased in July as well. So logically, it's kind of consistent. Yeah. Okay, we go further. Our main point is what happened to the crop yields, right? So we focus on the maize yields. This figure, we can see the maize yield, it increased. So our results is 0.4 ton per hectare. And at the same time, the production shortfall probability reduced by 25%. So it's all of them, it's based on our model results. So I need to give more analysis about why it happened like this. So it's our mechanism analysis, or you can call it pathways. So first, the program reduced the harmful degree days by around 5.57 Celsius degree day during the growing season. But the growing degree days is not significant. So that means the temperature reductions actually occurred during harmful extreme heat events. That means only the harmful degree days get decreased, but not the growing degree days, because growing degree days they are positive to the crop years. And the second pathway is the maize reproductive growth stages were extended, which means during the growing season, the crops got longer time to grow for the crop filling. So that means the yield would be higher. Yeah, it's about agronomy, so it's not that easy to understand. You just think, okay, the crops get a longer time to grow, so the fruit get bigger. You can understand it in this way. So how long it extended is about 0.93 days. And the third one is, of course, is rainfall. Yeah, the rainfall is quite significant, although it's only increased in July. But actually, July is very important for the crop growing, especially for maize in this area. So here is for calculating all the pathways, how much the pathways can explain our results. Actually, it's based on the reviewers' comments. I think it's very useful, so I share you with here, but it's a part of the appendix. Yeah. So the extreme days and also the growing period actually plus the rainfall impacts in the end, it can explain 65% of the maize yield increases. It's not 100%. It's actually the local climate change only can explain 65%. But further, we found there's other ecological pathways as well. For example, the windbreak and the sand fixation. There is one paper which is published in American Journal of Agricultural Economics. They explained why the sandstorm impacted the crop yield. And here we use the windbreak and the sand fixation. Actually, it's the same thing. And also the soil moisture. Yeah, in the end, we add this with our local climate pathways, it can explain 93% of the growth. And also, of course, other potential channels, for example, the pest and the disease, but we don't have data on this part, so we just talk about it. And we check the others, for example, whether the yield, the maize yield increase because of the planted area or the total agriculture area is not significant, but only the total production got increased. So that means that the yield got increased. It's not from the area. We also checked whether this policy impacted the agriculture inputs. Yeah, so no, actually. I think my time is going to be finished, so I will be very fast, 2 minutes. And also we checked from the biophysical mechanisms, so the biophysical pathways. So it's more from the atmospherical sense, and because of the time limitation, I will skip here. And heterogeneity analysis. In the end, we did the cost-benefit analysis and also checked the spillover effects. We also checked the impacts on other crops. Of course, our results should be very reliable, so we did a lot of robustness check. For example, we used the PSM-DID, and also we used the two-stage OLS to solve the potential heterogeneity issue. Oh, sorry, not endogenous issue, sorry. Yeah, it's also a robustness check. We checked the we checked the if we consider about the initial situation, what would happen. So that's what is about. And others, we checked we did the parallel trained sensitivity analysis and also the penicillin test. So all these things are just to check whether our models are reliable. The main findings, yeah, like what I said, we proved the grassland restoration improved the maize yield by regulating the local climate. So we did this figure based on our event study results. So the conclusion of the contribution is first, we proved the ecological conservation can significantly improve agricultural yield when local climate benefits are accounted for. And second, we provide empirical evidence that large-scale grassland restoration effectively regulates the local climate. This challenges the prevailing assumption in agricultural economics that climate is exogenous. Ecosystem restoration is thus not just conservation, but a strategic investment in climate adaptation and food security, offering a clear win-win for people and the planet. Yeah, that's it. Thank you.